Look closely at this airplane.
The fastest jet ever built looks unfinished. See those seams? Those gaps? On any other aircraft, this would be a failure, bad construction, poor quality, a mistake. But this isn't a mistake. This is the SR-71 Blackbird, and it was never designed to be perfect on the ground. At extreme speed, the air doesn't just move past this plane, it attacks it. The skin heats up, the metal changes, the entire aircraft physically grows. Panels slide, seams tighten, gaps disappear. The plane reshapes itself in flight. If engineers had built it tight on the ground, the expanding metal would have crushed the airframe in the sky. It would have destroyed itself. So they did something that feels wrong. They built it loose. Even the fuel tanks weren't sealed. On the runway, the Blackbird leaked. In the air, it sealed itself. But the gaps aren't the strangest part. The metal itself is a paradox. To survive this kind of heat, you can't use normal aircraft materials. They would soften, warp, fail. This machine needed a metal that almost no one could supply. The only place with enough of it was the enemy. So the United States did the unthinkable. They created front companies. They quietly bought the metal from the very nation this aircraft was built to spy on. The Blackbird was forged from material sold by the country it would outrun, outfly, and outlast. A ghost built from enemy metal. Then there was the fuel. You've heard it leaked on the ground, right? So why didn't it explode? Because this wasn't normal fuel. It was designed not to burn easily, to stay stable, even when everything around it was cooking. You could try to light it, and nothing would happen. So how do you ignite an engine like that? With a chemical reaction violent enough to wake it up. Every time the pilot advanced the throttle, a small controlled chemical ignition kicked the engine alive. A flash, a bang, the beast breathing fire. And finally, the engines themselves. See that spike in the intake? At extreme speed, air moves too fast for a normal engine to survive. So that spike constantly adjusts. It captures the shock wave and slows the air down just enough to keep the engine alive. If it fails, the shock wave enters the engine. The engine explodes. The aircraft violently lurches. The pilot feels it instantly. This machine lives on the edge of destruction. It leaks. It expands. It burns chemical igniters just to function. On the ground, it looks broken, loose, imperfect. But in the air, at extreme altitude, at impossible speed, it becomes the only thing that makes sense.